Welcome back. This is part 4 of my review of Shmuel Pollen's book, All In for God. We got a bit of flat earth stuff to finish up, and then we're on to denying the number pi and that 1 + 1 is 2. If you think I'm joking, I don't joke. I've never told a joke in my life. This is a serious channel. Seriously, I'm not joking.
Here is another observation. You can see the Chicago skyline from Michigan, 60 miles away.
I'm glad you left that credit there to Joshua Nowicki. Made it nice and easy to find. So he's a photographer who's spent some time taking pictures of mirages and similar effects across Lake Michigan. And this particular one is a very nice example of looming, which is an atmospheric refraction effect related to a mirage, where a temperature inversion makes the atmosphere act something like a magnifying glass, bending light down to your eye without the mirroring and duplicating effect that's associated with mirages.
So if you're looking at Chicago here, just maybe now you can just see the top of the Sears Tower, and if our simulated temperature inversion moves into place, hopefully now you can see pretty much all of Chicago,
see all the lower buildings,
including what's at ground level.
So the atmosphere really is acting like a lens.
Yes.
The guy looking through the magnifying glass is Tom Coombs of ABC 57, who did a really good piece on this that pretty much says everything that needs to be said. And so I'll go through a few clips and then move on.
The views along the lake are always changing, along with the weather.
It's always different. It's so unpredictable that I want to catch as many different views of it that I can. Every day is different. The view you see across the lake or the lake shore, the waves, the clouds, the sun, everything's different. It's always something unique to see. It's a new experience every single day.
Because this is a product of atmospheric conditions, this effect is highly dependent on time of year, time of day, weather conditions, dumb luck. And even when you manage to see this specific effect, you're not going to see it the same way every time. What you'll see is more or less of the Chicago skyline depending on how much of a lensing effect the atmosphere is causing, showing that what you're seeing isn't as real as you think it is.
That picture from a year ago, that's looming, as are these photos that we snapped. This is a mirage. We caught this looking towards Michigan City. Notice the distortion or flip in the image in the time lapse. On a normal day, say in the summer, you can see Chicago, but only a dozen or so of the tallest buildings.
In this clip, you can see the buildings appearing to come in and out of existence along the temperature inversion. Watch carefully, Shmuel.
We can see out on the horizon and above it a dark line that's starting to show up just above. That's the inversion. That's where temperatures are different below than they are above, and creating that cap.
I'll play it one more time, but slower.
Just above. That's the inversion. That's for temperature.
So what's seen in the picture is real, but in the sense that an optical effect is real, not in the sense of you seeing the actual buildings across a flat plane. On a day without a temperature inversion, you're not going to see this at all. And if there is one, you're not going to see it stay consistent because this is not what you want to think it is. And the photographer is just as aware of this as everyone else is, which is why he took a picture of it. Because it's a really neat observation. It's one that's way cooler and more instructive about our world than you will ever give it credit for.
If the Earth is 3,965 miles in radius, using the Pythagorean Theorem, there are 8 inches of curvature per mile squared. According to this basic geometry, if curvature actually existed, Chicago would be miles below our view. You would never be able to see any of it, unless the Earth is flat.
Okay, let's see. I know the 8 inches per mile squared thing is just a really old and kind of bad approximation. And I say bad because it's parabolic, and so it starts to lose accuracy really bad beyond a certain point. And that point is actually beyond this distance. It should be fine to this distance, but you didn't say to use it anyway. For some reason, you said to do it using the Pythagorean Theorem, and then you did it a completely different way. So I'm gonna take your advice and use the Pythagorean Theorem because it's better. So we draw a circle, that's our Earth. We draw the radius of the Earth, that's 3965 according to you, fine, we'll use your numbers. We draw another line, very much not to scale, obviously, but just for illustration, which is the distance that we're looking. I checked Google Earth for the distance from Warren Dunes, where the photo was taken, to downtown Chicago, where these tall buildings are. And it's about 53 miles. You said 60, the news guy said 50, I'll go with 53. A squared plus b squared equals c squared, so 3965 squared plus 53 squared equals 15,724,034. Square root of that is about 3965.35. Subtract away the radius of the Earth. It's about 0.35 miles, or like a couple thousand feet. That's more than the height of the buildings, for sure. I agree, they're far enough away that you won't see them without the looming effect, and of course you don't, which is good evidence that the Earth is not flat. But you said miles of height should be hidden, and that's just wrong. Now, for the sake of thoroughness, I also did the math with your 8 inches per mile squared approximation, just to see how you got miles of drop. So 53 miles squared is 2809, times 8 is 22,472 inches, divided by 12 inches per foot is about 1873 feet, divided by 5280 feet per mile is about 0.35 miles, which is exactly the same as what I said based on the Pythagorean Theorem. As I said, this works because we're not considering large enough distances for the difference between the two methods to really rear its ugly head. This method will fail miserably at distances that are realistic on Earth. But if the two methods that you recommended using get the same result of 1/3 of a mile, how the hell did you end up thinking the result is multiple miles?
Another observation. Independent weather balloons have been floated 30 miles up and revealed that the Earth is flat. See the video at YouTube, Weather Balloons Flat Earth.
That's of course not the title of the video that picture's from, nor do you give me any identifiable reference to that video, so I'm really happy about that little sign there that says dog cam because that was how I found it. Now, very interestingly, the image you show here is not some frame of video that you found especially compelling, it's just the thumbnail. It honestly makes me wonder if you actually put in the effort to click through to the video. But I did, of course, and the very first thing I checked for was image distortion. And oh boy is there ever image distortion. Look at that horizon warp. Yeah, this camera obviously has a fairly wide-angle lens, and that's going to throw off any attempt you make to observe curvature using this footage. That's not what this video is for. It's not fit for that purpose, so it's meaningless. But I can play this same stupid game if you wanna. Here's a different screenshot. Curvature! He goes through a couple more of the worst flat earth arguments, and I just can't be bothered anymore. And then he says you can Google for 200 more flat earth arguments, and then says,
if you want to remain a ball earther, you have your work cut out for you. You will need to debunk every single one of these 200 proofs or change your viewpoint. Good luck.
What is it with this guy in this argument? I'm gonna waste as much of your time as I possibly can by raising as many arguments as I can, regardless of their quality, and if you don't spend the rest of your life debunking every single one of them, you have to agree with me. Nope, I don't. As I said before about this, I don't have to engage with you. I don't have to change my mind about anything, especially when the only reason you've given me to is telling me that you're intentionally wasting my time. If you want me to believe you, you have to stop being lazy and put in the effort. And I don't mean telling me to Google for 200 arguments or I have to obey you. I mean the effort of putting together a really great argument, or maybe a few, so that you have something really compelling and convincing to tell me so I might actually decide to do what you want and agree with you, instead of just seeing you as incredibly dishonest and pathetic and lazy.
If you believe in your own eyes more than you believe in what scientists tell you to believe, you will believe in the flat earth.
What happens if both of those are the same thing, as they are in my case? Then what? Are you going to tell me to believe some random jerk-off who wrote a list of 200 bad arguments I found on Google instead? You're telling me to believe my eyes, right? So why should I believe his eyes or his reasoning over my own? Especially when inevitably his observations and reasoning turn out to be as silly as yours. Why should I just believe the magician actually turned a stick into a snake despite noticing the sleight of hand?
Here are some fun questions for teachers who teach the spinning globe Earth.
Get ready for a splitting headache.
You. If we're on an extremely fast spinning globe, why don't we all fall off of it? Her. Gravity, or magnet in center of Earth.
Please tell me you made that up. Please tell me your high school teacher didn't tell you the Earth's magnetic field is the reason you stay on the ground.
You. If the gravity is strong enough to stick me to the ball, why doesn't it stick birds to the ball, which are much lighter than me? Don't expect a good answer.
Ow, ow. Oh, my head. Okay, Shmuel, next time you see a dead bird on the side of the road, pick it up, drop it, and watch it float off into the air because it's lighter than you. I'm sure that'll work, and the whole powered flight thing is just a hoax. You know, I like that even in Shmuel's fantasy, the teacher didn't bother to dignify that with an answer. She's got standards. I don't.
You. Can you prove either of these exist, gravity or magnetism? Her. She drops something to prove gravity. You. That happened because the thing is more dense than the air. If you dropped a helium balloon, it would have fallen up. Why doesn't gravity make the helium balloon fall down? Don't expect a good answer.
If it's density, why doesn't it stick birds to the ball, which are much denser than air? So that's another one the teacher didn't find worth answering. But if you understand the idea of gravity, whether you agree with it or not, the answer is obviously yes, gravity does pull the balloon down, which is why when you put a helium balloon in a vacuum, it falls to the floor. So why does the helium balloon go up when it's in the air? Well, because buoyancy is a direct consequence of gravity. Its upthrust is only meaningful in opposition to gravity's down. Without gravity, or something precisely equivalent to gravity, defining what down even is, buoyancy ceases. And I'm sure, like so many flat earthers, you would respond by saying, gravity isn't necessary, it's just buoyancy acting through density, which leaves a massive gaping hole in the middle of the problem. What are up and down exactly, and why, and what exactly is defining these directions? Why do denser things go down and less dense ones go up? Buoyancy can't explain it because buoyancy depends on up and down already having been defined. It's based on up and down, it doesn't cause them. The only buoyancy answer fails so miserably because it answers just a superficial question while ignoring the one that actually matters, the one that explains buoyancy. And that explanation is there's something that defines up and down based on the direction objects are pulled, and this is what's referred to as gravity. Now, go ahead, disagree with modern explanations of how exactly gravity's action is caused. Say, no, it's not space-time, it has nothing to do with mass, anything like that. It's just angels pulling everything down to mess with us. Fine, whatever, it doesn't matter at this point. But if you want buoyancy, you have to have something that acts just like gravity acts, regardless of what it actually is. And flat earthers, at least some of the ones I've dealt with, take this necessary precondition and toss it in the garbage, thus gutting their whole idea of any explanatory value it might have had, and they don't seem to even realize what they've done, or why people laugh at them for it.
How can you be so sure about what's going on in the center of the Earth when humans have only dug 8 miles down? Don't expect a good answer.
Okay, well, judging by this photo, we should be digging around the North Pole where the magnet's closest to the surface. Now that's the magnet, but for the gravity we might have to dig somewhere else. Wait a minute! The South Pole of this magnet is at the North Pole of the Earth! And the oceans were never this shade of gray in other Earth photos I've seen. This is a Photoshop fraud!
Even if there is a magnet, wouldn't it need to be much stronger when the people are on the bottom than on the top? How does that work? Don't expect a good answers.
I asked Shmuel about gravity in an email, and specifically I asked him, if gravity were true, what would be its effect on the meaning of up and down? And his answer was he doesn't believe in gravity. I told him, right, I know, but you're arguing against gravity, so you must understand what this idea is that other people hold, and I just want to see if you do. And his response was that he doesn't need to understand the opinions of people he disagrees with to have an opinion. He doesn't need to occupy himself with false religions and debunking everyone, which actually, by his own standard, yeah, he does. He has to debunk literally everything anyone ever says about anything or everyone but him is right. But yeah, he has no clue what the idea is that he's arguing against, and he knows it, and he doesn't give a damn.
This is as far as he or she will normally be willing to go.
Yeah, I noticed your imaginary fantasy teacher stopped replying to you 3 questions ago. Can't say I really blame her, when you're clearly strawmanning everything she says on purpose.
The world is a globe, right?
I mean, Aristotle said so, he's on my side. Not only that, but he calculated its circumference. And he lived way before us, and he was way more like God, and nothing he says should be taken with a grain of salt.
This is an intellectual giant, and nothing he says should be taken with a grain of salt. Aristotle was awesome.
And the ground is always below me when you're flying in a plane, right?
No, the ground is below me when I'm flying in a plane. It's below you when you are. Although actually, assuming you haven't gone underground, if I'm on a plane flight and you're not, the ground's probably still below you.
Wouldn't my plane then need to be upside down when I'm flying across the bottom, or sideways when I'm flying across the equator? Does your plane ever travel upside down during a flight? Does it even seem to turn completely sideways for an entire flight? No.
It's such a ludicrous straw man, I can barely believe you're stupid enough to be saying it honestly. But then again, it's also pretty stupid to intentionally avoid understanding a position you aggressively argue against for page after page of a book with your real name on it. Maybe it's not dishonesty or stupidity. Maybe it's just what I mentioned before. Your incredible level of laziness. Hey, you remember what you said way back on page 20?
I thought back to my college days on the debate team.
Well, it goes on from there.
I once had to argue a position I was told to adopt for 10 minutes. Then the teacher says, now switch cards. Take your opponent's position for another 10 minutes.
Just imagine this guy on the debate team having to argue in favor of a spherical Earth. I believe planes fly upside down in the southern hemisphere because, I worship Albert Einstein and I want to arrest geocentrists like Galileo. Gravity means all the water should flow off the bottom of the Earth and gather up on the tray at the bottom of the universe. But that doesn't happen because flat Earth is correct, but I hate the Bible, so I pretend I never said that. Thank you, hail Satan.
Science is constantly using math to express their ideas, so the universe seems more fixed than ever. And once again, when they do so, they reveal that neither they nor their equations have any clothes at all. And once again, even a child can see it.
Well, that's just what I need, a child to teach me math. Up until this point, those of you who watch my videos or otherwise pay attention to this kind of discussion have probably heard someone espouse most of the positions we've heard. But I think that's going to end now because what we're about to look at for the next 30 pages is full-blown denial of mathematics. The next chapter is called Math. Is pi a lie? He spells lie, L-I, and it's about as funny as that dead bird I imagined him picking up off the side of the road. Fortunately, the chapter itself is as funny as his face when that bird failed to float off into the stratosphere, which is to say hilarious.
There is no magical pi number. In fact, every single circle on Earth has a different pi. This fabulous number, 3.141592653588979, is a fiction! It does nothing for you but make you think mathematicians are gods. Apparently not. Apparently at least one mathematician, the one who invented this number and turned it into a false god, is apparently a fraud.
Since you don't say who you mean, let's just say Archimedes. But he lived in 250 BC. He was way closer to God than we are, and that's way more intelligent and perfect than you. Why would I believe you over him, Shmuel? What are you, some kind of atheist?
If you don't believe me, run the experiment yourself. Draw a circle with a compass. Take some string. Run it from one side of the circle to the other. Measure the string exactly. Then wrap that string around the circle. See how many times it takes to get the string around the circle. Do it with a few circles. Here's what will happen. Every circle you try this on will give you another answer.
Of course it will. Your method has a ridiculous level of imprecision. The potential for measurement error is just insane. What did you think was going to happen?
Yes, there is more than one pi. There is no magic number. Pi varies wildly. Look online and you'll see people have gotten results as high as 3.40. We've been lied to.
Random unspecified internet jerk-off fails at measuring a circle with a string, proving math is a false god. More at 11.
This is what science and math always do. Something is a variable, it constantly changes, and they fix it. They decide on a certain number, always a very large one, and it impresses people.
3 point something is a very large number?
But that isn't right. Tell the truth. This number changes constantly, and that big magic number is made up.
It's barely more than 3. I have more fingers than that on one hand. What a strange complaint.
That's one layer of falsehood, i.e. fixing that which is not fixed to impress people. Here's another. They told you that this non-existent number goes on forever without ever repeating a sequence.
No, they did not. They told you that at no point does it just start repeating one sequence over and over and over again forever. Of course it has repeated sequences, an infinite number of repeated sequences, in fact. Once again, we see you just not bothering to figure out what you're even arguing against. You don't know what it is, you just know you don't like it.
As if it's some kind of miracle of biblical proportions.
No. It's incredibly common. There are infinitely many numbers like this, in fact. For example, the square root of any integer is irrational unless it's a perfect square. That is, unless its square root is also an integer, like the square root of 9 is 3. So the square root of 2, and 3, and 5, and 6, and 7, 8, 10, 11, 12, and so on like that forever are all irrational, just like pi. This is not something special about pi.
This is what really got the songs and poems started. Well, sorry to spoil the fun again, but lots of numbers do that, not just pi.
Yeah, that's what I just said. Why are you telling me this like it's news to someone? Pi being irrational is not impressive. In fact, it's more kind of just annoying. If pi really were just 3, that would be insanely handy, and also kind of impressive. Way more so than some junky irrational number that means calculations on a circle are always going to be imprecise. Of course, getting enough precision is usually not a big problem, but still.
You can create these numbers yourself in many ways. Just take out a piece of paper. Write 1.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. See what I did there? That string of numbers after the decimal point will go on forever, and it will never have a repeating sequence. When do I get my Nobel Prize?
Of course it'll have a repeating sequence. You're just typing out every integer in a row. 1, 2, 3, and so on, up to 16 in this case. And presumably you mean to imply we're going to keep tacking on each integer one by one forever. You don't have infinite digits, you have 10 digits, and so it must have repeating sequences, and it already did. 1, 2 showed up twice already. 2, 3 is going to be a repeat, 3, 4 is going to be a repeat, 1, 2, 3, 4, 5, 6 is going to be a repeat. It'll have infinite repeated sequences, which is fine, because to expect anything else from an infinitely long string of only 10 possible digits is just silly. Seriously, who told you this is special or unique or anything people actually find useful about pi? Well, he brings up the fact that people round pi to actually use it, which of course they do. It's an irrational number, they don't have a lot of choice.
The number 3.14000 is a cop-out. It's not being true to the magical pi number, which is supposed to exist, so it's already wrong according to your paradigm.
Yep, that'd be what rounding is. Using a value that's technically wrong to some extent, but not wrong enough that it matters. Good enough precision, not perfect precision, which simply is not expected when you're doing math on irrational numbers. As I said though, it'd sure be handy if pi were just 3 or 3.14 or something like that. Everyone would prefer that, but it's not that, so all we can do is get on with it.
Further, according to my paradigm, it will almost never be correct because there is only one circle in the world whose pi is 3.14000.
Huh, so if a ratio inherent to the definition of circle is actually instead a function of the size of a circle, how big was the circle the guy measured to 3.4 with a string? Was it super huge or something? Like football field size or bigger? Or was it just drawn on paper with a handheld compass? I mean, if he's just cutting up little bits of string to measure it, it doesn't sound very big. But presumably, other similarly small circles drawn on paper get significantly lower values. Probably some a bit less than pi, even, using that method. Now I, being not a complete dumbass, would attribute this to measurement inaccuracy, since it involves fiddling with bits of string and trying to kinda sorta get it about right-ish. But you attribute it instead to pi actually changing with the circle in some way. So what I'm trying to ask is, does it change wildly, randomly? Like for example, does a circle with diameter 1 have a pi of 3.1, and then diameter 2 is 3.3, but then diameter 3 is just 3 even, and then diameter 4 is like 3.8? Or does the ratio scale in proportion to the size? And by the way, how exactly does a ratio unrelated to the size by definition scale with size? You endorsed the use of the Pythagorean Theorem earlier. What you're saying here kind of has the same tone to it as saying a squared plus b squared equals c squared plus or minus like 20% depending on the size of the triangle.
That's a mess. You could just as well do without it. Just measure the diameter and call that the size of your circle. End of story. Size equals d. We can all agree on the size of the straight string.
Great, I'm sure that'll do wonders for us when we're interested in the length of straight lines. By the way, speaking of the Pythagorean Theorem, which apparently you accept, did you know you can approximate pi to arbitrary precision using it? In a very simple but repetitive and boring and time-consuming process? It's a lot easier if you get a computer to help. The author of this webpage managed to get to 9 decimal places before the double precision floating point variable killed the precision, but if you took the time you could do this to any precision you wanted. And now you have pi defined in terms of triangles in the Pythagorean Theorem. So now you'll at least accept that pi is not, say, 3.4. If Pythagoras was right, it's at least close to what we think it is, right?
Some ask, I know pi doesn't work now, but why? Why doesn't pi work? Shouldn't all circles measure out the same way? If all circles are perfect, they should all have the same ratios, right? The size of the string can change, but the number of times the string goes around the circle shouldn't change because all perfect circles have the same dimensions, proportions, or ratios.
Yes, by definition of what a circle is, yes, correct.
Correct! It should work, but it doesn't, and here's why. It's called apples and oranges. You can't mix them in an equation. When you measure a line in inches, for instance, you can't just bend that line, measure it again, and assume it's still in inches.
So what's the deal with those circumference measuring tapes that do both straight stuff and circumferences?
It's now in a completely different metric. The metric for bends is not the metric for lines. There is no metric for bends because bends and circles are incalculable.
My sticky note for this part just says, where do I even start? With 4 question marks and 3 exclamation marks. And I'm in the same boat now as past me was. Where do I even start? I guess what I should do here is try somehow to figure out at least what point Shmuel thinks he's making. And for that, I think we have to go back to the number 1 philosopher, who Shmuel never takes with a grain of salt except all the different times he does. Aristotle. And I think this comes from his Physics, Book 7, Part 4. But may we say that things are always commensurable if the same terms are applied to them without equivocation? E.g., a pen, a wine, the highest note in a scale are not commensurable. We cannot say whether any one of them is sharper than any other. And why is this? They are incommensurable because it is only equivocally that the same term sharp is applied to them, whereas the highest note in a scale is commensurable with the leading note because the term sharp has the same meaning applied to both. Can it be then that the term quick has not the same meaning as applied to straight motion and to circular motion, respectively? That's the end of the quote. So there we have the apples and oranges analogy, although Aristotle uses pens and wines and musical notes. And we have the denial of equivalence in length between a straight line and that same line bent, although expressed in terms of speed along a path. Velocity is distance over time, and the time surely in Aristotle's time was thought to be the same in any case. So really he's questioning equivalence in distance. At least I think so. I haven't done like a deep dive into this. I'm just trying to see maybe where Shmuel's getting his ideas. The real question here, I think, is, are we talking about imprecision in physical measurement or imprecision in calculation? Well, we were talking about physical measurement before, and it kind of still sounds like we are. Like if you bend the string to go around the circle, the string has width, and so the inside is compressed a bit and the outside is stretched a bit, and so the width of the string causes some amount of measurement uncertainty depending on which exact part along the string's width that you measure. Maybe? Which really should not be that big of an issue if you're already prepared to accept perfect precision of string-based measurements of pi at 3.4 from random people online without the thought of inaccuracy even crossing your mind. At that point, the width of the string is pretty damn negligible. On the other hand, if we're talking about calculation, one way is just to break up the circumference into an increasingly large number of straight lines and then measure those, to get a value that gradually approaches the real value. And that's the general idea behind what I showed you with the Pythagorean Theorem, and it's the general idea behind a lot of ways to calculate pi. Using geometric objects with straight edges, right triangles, polygons with increasing numbers of sides, and then repeating it with smaller and smaller chunks to constantly improve your estimate. Now, those methods are never going to reach perfect precision because pi is irrational, but they'll get you as close as you could ever seriously care to get if you iterate them enough times. And assuming you iterate enough to get a few decimal places in, you will never get a value like 3.4. And it doesn't matter what size the circle is. That Pythagoras method is going to converge on the same value with any radius you feed it. It's not a function of size. It's a property of the shape itself.
Circles are beyond measurement. We're soon going to hear about a meditation on pi. We should be meditating on this, the transcendence of the circle over all our methods of measurement. But instead of realizing our limitations and recognizing the glory of the incalculable circle, a creation of God, your geometry teacher tried to tell you he could do the calculation. He could accurately size a circle, and he said he could do this thanks to pi. Lies on top of lies.
I still don't understand this desperation for the universe to be nonsensical, inconsistent, incalculable. What has led Shmuel to think this is so necessary and foundational to his belief in God that he has to throw reality out the window? He doesn't like the earth to rotate because somehow that makes the ground unsolid and it's bad for children to believe. But he doesn't want anything else to ever be solid at all. And that seems like a deep emotional commitment, not just some intellectual confusion. I'd love to learn more about why he thinks this way, but I just don't see that happening.
As far as bridges and tunnels and architecture go, I would bet quite a lot they don't use pi. They only use diameter. That's all you need.
Not only do you not need pi, you don't need to know anything about any curve at all. You know, if you feel comfortable driving on some crazy huge modern suspension or arch bridge designed by a trigonometry and calculus denier, feel free, I'll stay home.
And this line about bridges, of course, is another lie, because bridges worked just fine before pi was discovered.
Wait, what bridges are we talking about? Pi's been known, roughly at least, for thousands of years. I mentioned Archimedes. Around 2300 years ago, he managed to estimate it to between 3.1408 and 3.1429 using polygons with increasing numbers of sides, which is pretty damn good for the time. And certainly usable for any bridge until, like, I don't know, possibly now even. 3.14 might be good enough. I don't know about bridge design. I don't know what kind of precision they need. But we're not talking about a little bit of rounding here. We're talking about declaring it incalculable and never using it at all. Now, it wasn't just the Greeks who were approximating pi. People from other cultures had pretty good approximations too, although not that good. Really, what bridges are we specifically talking about here? I'm gonna guess something Roman, probably. In which case, yeah, I'm pretty sure they weren't using pi. More like a lot of trial and error and rules of thumb that they managed to figure out about ratios and heights and widths and so on, which probably would have been a hell of a lot easier with pi and a better number system. But their construction was also much simpler than modern construction and smaller scale, and inaccuracy was compensated for by over-engineering, which also means increased resource usage, which also means increased cost. And today we have all sorts of mathematical tricks to avoid that, like pi, and all the math based on pi that I'm sure your engineer rabbi was very familiar with and used often.
We all better pray they don't use pi to do anything practical, because that would actually cause a danger of collapse.
I don't know what to tell you, man. It seems to be working out all right.
But no, pi is holding our society together, not God. Pi is a god, all right. A false god.
I still don't understand this attempt to paint pi as a god. I guess it's because modern mega construction involves math, and therefore people deny that bridges and buildings are just held up there by God's whim from moment to moment as he recreates the universe. What do you want me to do next? Deny the existence of stone and steel and concrete?
The damage to children is that they are worshipping a number instead of God, who is the one who created the circle.
Did it ever occur to you that if you want to do weird stuff like teach your kids to worship the god of circles, you can do that and also teach them the ratio of the diameter to the circumference? These things aren't mutually exclusive, you know.
God gave us this shape that defies all our methods of measurement, and it is so beautiful and useful.
And way more beautiful and useful when you understand that ratio. But so the issue is, you don't want this ratio describing this particular aspect of what a circle is to be quantifiable. The diameter, for some reason that's fine, but the ratio of the diameter to the circumference, hands off. Or at least it has to defy measurement. Well, it's going to do that regardless if we're talking about perfection. Since pi is irrational, there's no way to ever get it perfect. There, you got your mysterious, unmeasurable property back. Now suck it up and deal with reality, you big baby.
If you must worship something other than God, let it be the circle, not pi.
You sure you'd be fine with that? I don't believe for 1 second that you would be any more fine with me worshipping circles than worshipping a ratio related to circles. Now, of course, nobody's worshipping pi. Shmuel had some example of some guy worshipping pi a couple pages ago, and really all it is just that there's some guy who competes in pi memorizing contests and runs through the numbers while he meditates, which I guess helps lock them all in. That's not what worship means. That's just enjoying using your memory.
The task given to we humans is not to try to explain a world without God. Turn that upside down. The real task is to try to find him in everything we see. We must try to keep up with his mind-boggling abilities through his creations as best we can, so we can show proper gratitude for it all, to see how just as he is unfathomable, his universe is unfathomable.
Right. There's no intellectual root to any of this. It's all emotion all the way down. A strict emotional commitment to believing everything has to be nonsense and there is no stable ground. Look, buying into some religious belief in a creator being is one thing. And believing that some things about the universe or about your God are incomprehensible, I also understand. But buying into a belief that if you believe in God, you have a religious obligation to see the universe as totally incomprehensible to the extent that you'll start denying parts of it that clearly are comprehensible to some extent, that's something I haven't seen much of. And it's odd because most religious people really don't seem to have a problem with this. If they believe in an incomprehensible God, they tend to say, oh, how wonderful our unfathomable God is to have created this comprehensible universe that allows us to survive and thrive so well. This thing that can be so elegantly described through math and logic. What a miracle. Praise God. Which of course is also something I have issues with, but it seems a hell of a lot more sensible than insisting that nothing can ever be understood in any way at all. But again, I really have to point out, you don't actually do that anyway. Not consistently. Your previous chapter about the flat Earth had the exact opposite message from this one, that the universe should be instantly comprehensible to perfection just by walking outside and looking around, and to say otherwise is anti-scientific and anti-biblical. I'd tell you to pick one, but hey, maybe you did it on purpose just to create a bit more unfathomable inconstancy in the universe. Everybody's got to do their part, right? Now, all this pi stuff was pretty bad, but it's about to get worse. Much, much, much worse. The next chapter is called 1 + 1 = 2. Is it enough if I just stop there? Do I really have to engage with this? I don't wanna. You know, I didn't even bother sticky noting this part. I just couldn't handle it. I went and bought 600 sticky notes for this project, and I would have ran out. But I know you'd skin me alive if I skipped it, so here goes.
In short, the answer is no, 1 + 1 = 2 is not a true statement. It is correct sometimes, but not always, and that makes it a half-truth. In other words, a full lie. This will strike at the core of our unshakable belief in math, as the most rock-solid and perfect belief system on Earth. It isn't.
Look, I'm gonna go through this chapter because, I mean, I honestly can't pass this up. It's gold. It's the funniest thing in this whole book. But don't expect me to go in depth arguing against this festering shit pile. If Shmuel wants to deny actual kindergarten math, I'm absolutely fine with him doing that. And in fact, I want him to continue doing that, because the more ridiculous he is, the more entertainment I get. He brings up the example everybody's taught of one apple next to one apple being two apples, and this seeming so obvious and observational that we never questioned it again. But then he brings up something I'm sure none of you have ever thought about in your entire lives. It's revolutionary. 1 + 1 objects, must be precise, can be combined into one object.
So what if, instead of an apples, the teacher pulled out pieces of clay? She puts it on the table, then she adds another piece of clay.
Okay, so she had one piece and one more piece. That's 2 pieces. So 1 + 1 is 2.
But she sticks it up against the first piece and squeezes them together. How many pieces of clay are there now? There is 1.
Okay, so we're only concerned with the number of clay balls at any given time, not the quantity of clay per ball, the size of the ball. Fine, works for me. So we take 1 + 1 is 2 clay balls, and then we subtract 1 clay ball from the total, in this case by absorbing it into the other one, to make 1 clay ball. So step by step, that was 1 + 1 = 2, 2 - 1 = 1. So far so good. Wait, there's gotta be more, right?
The right formula for that case would be 1 + 1 = 1.
That's wrong.
That's right.
No, that's wrong. When you had 1 clay ball and 1 other clay ball, you had 2. 1 + 1 is 2. Then you subtracted 1 by making it part of the other one. That's a subtraction operation, not addition.
There is more than one answer to the question, what is 1 + 1? I would need to know, what kind of addition are we using? There are many kinds. I told this to someone once and he said, yes, but now the clay is twice as big. This is a logical fallacy. First, because I never said the pieces were the same size.
It's an unwarranted assumption, so it's incorrect thinking, I'll give you that.
Second, because we are currently in the business of counting amounts of objects. Focus on quantity of pieces. Don't be distracted by size or weight or mass, which is a separate discussion.
Alright, and that's what I did. I played by exactly your rules. I focused only on quantity of pieces. You had 2, then you had 1 less than 2. 2 - 1 = 1.
If she took the 2 apples and put them into a food processor and came out with 1 applesauce, then again the formula would be 1 + 1 = 1.
No, that would be 1 + 1 apples is 2 apples. Then you blend them together and now you have 2 blended apples. If you're just counting objects and you count the applesauce as 1 object, then again you have 2 objects minus 1 is 1 object.
What happens if you have a lake and you add in a bottle of water? How many bodies of water do you have now?
Well, I wouldn't exactly call a bottle of water a body of water, but if you insist, 2 minus 1 equals 1 body of water.
1. Just the lake. 1 + 1 = 1. What if you add a sperm to an egg and you wind up with 1 zygote? How many objects do you have now? 1. 1 + 1 = 1.
1 sperm plus 1 egg is 2 objects. Combine them into 1 zygote, that's 2 minus 1 is 1.
Examples of 1 + 1 = 1 are everywhere. If you add salt to your soup and it dissolves into it and disappears, how many ingredients do you have now?
How should I know how many ingredients there are? You didn't even tell me what kind of soup it is.
20 granules of salt, now gone, and we just have soup.
Okay, but you asked how many ingredients we have. Soup is not a soup ingredient. Salt is an ingredient, so that's 1. Is it salt soup?
So we have 1 ingredient. 20 + 1 = 1.
Wait, 20 salt grains plus 1 what? What's the 1 of some other ingredient? What are you talking about? If you just have 20 granules of salt and they dissolve, that's not even an addition operation. Okay, how about instead of this weird thing you're doing, we just count objects again? The soup is 1 object, and each granule of salt is also 1 object. So that's 20 + 1 = 21. Then we combined the salt objects and the soup object together into 1 object. That's 21 minus 20 = 1.
And when you take 1 husband and 1 wife, add them together, and they have a baby. That's 1 + 1 = 3.
You have 2 people, you add 1 more person, that's 2 + 1 = 3.
If they have 10 kids, that's 1 + 1 = 10.
Wait, so if they have 1 kid, now there are 3 people, but if they have 10 kids, now there's just 10 people. Shouldn't that be 12? What, do the parents just drop dead after kid number 10?
Is your head spinning yet?
Aching more than spinning, and not for the reasons you hope.
Sometimes I see a blackboard filled with a massive equation, and I think to myself, all of this is only true if 0 is actually an integer and 1 + 1 = 2 is always right. Both are in question, so all their work needs to be reviewed. They are clueless.
You are name callers. You like to call arguments names, like clueless.
Well, you just called every single person who uses addition clueless. What does that make you?
I fear a lot of time has been wasted on formulas that go nowhere and teach children things that are deceptive or can never be used in the real world.
Ah, yeah, that 1 + 1 = 2. I can't see any practical use for that.
I personally would like to see more time spent on practical math. Counting change, balancing checkbooks, calculating your income tax, or anything else people can actually use.
I'm sure the tax man just loves you. 1 + 1 equals really whatever I feel like. And that's leaving aside the fact that your whole next chapter is a total denial of the entire concept of division. How the hell is anyone supposed to do any of the stuff you just said under your conditions? Let me see here. I made $20,000 and it went into 1 checking account. That's 20,000 + 1 = 1. So my income was 1.
We see a common theme here with math and science. God makes a world. It's beyond our comprehension. We can't catalog it. We can't fix it. It's constantly changing, but they do it anyway.
You keep talking about how these awful scientists keep fixing the universe, making it firm and predictable and unchanging. And I just want to make sure we're clear. You're talking about the same people who came up with relativity and quantum mechanics? The ones who you say supposedly think there's absolutely no way to distinguish between the sun orbiting the Earth and the Earth orbiting the sun? Okay, just checking.
And make themselves in essence the masters of the universe, the arbiters of the knowledge, and the mockers of all who question them.
I imagine Shmuel goes around saying stuff like this all the time in his day-to-day life. He seems like the type. And I would bet this repeated worry about being mocked is based on a lot of mockery in the past. And he probably doesn't understand why it's fully, completely, entirely justified. Maybe he can't understand. That's possible. But you know, I think it's a lot more likely that really his only problem is that he's fucking lazy, and he never ever tries. He expects everyone around him to bow to his idiocy, to respect him for his ridiculousness, to pretend that he's right when he's constantly wrong. He's entitled, he's arrogant, he thinks he's the center of the universe to the point of redefining reality itself to suit his whim at any given moment. But he probably gets reminded day after day that nobody fucking cares what his whim is. All I can say is, for his sake, I hope he's not arrogant enough to do his own taxes.
Please, don't get me wrong, I love math.
Oh, spare me. Well, that's all for this part. One more to go. In the next video, we'll see how Shmuel completely debunks the entire concept of division. Thank you for watching this one, and if you would, please give the video a like and click subscribe if you haven't. If you like the channel, please do consider supporting on Patreon or Subscribestar, and huge thanks to everyone who does. To get videos a bit early, sign up to the email list, list.logicked.com, and I'll see you next time.